Hello, this is Mr. Best. Welcome to Chapter 9, Homework Questions 7 through 13. Question 7. Examine the solid below and explore using the 9-7 Homework E-Tool. So you can see the blocks here. On your paper, draw a possible map plan for this solid. So in terms of what we see one block here, and then another one stacked a row behind, so there's 2, and then another one stacked, so that would be 3. Then we go 1 here, and then right here, if you look, there's no block. So look how it's shown there. So we have a 0, and then behind that we have 2, and then we have 1, 1, and then once again 0. Find the volume of this solid. So if you just add up the numbers that we just counted, 3 plus 2 plus 1 plus 2 plus 0 plus 1 plus 0 plus 1 plus 1, that will give you a total of 11. Make sure we label units cubed. Question 8. Assume that two figures on a flat surface A and B are similar. If the linear scale factor is 2/5, then what is the ratio of the areas of A and B? So we're looking at the areas, then that means that we square 2/5, so it would be 4 over 25. If the ratio of the perimeter of A and B is 14:1, what is the ratio of their areas? So once again, 14:1, you then square each of those, and we get 14 squares, 196 to 1. So that would be the ratio of the perimeters. And then if the area of A is 81 times that of B, what is the ratio of the perimeters? Now we're going the other way. We're going from area to perimeter, so we want to take the square root of 81, and so therefore it would be 9 to 1. Question 9, find the area of a regular decagon with a perimeter of 100 units. So decagon is 10 sides. So if the perimeter is 100, then each side is a length of 10. So I'm going to set up the one out of the 10 triangles in the decagon. Since the base is 10, we can split it into 5. Then we're going to take 360 and divide that by the 10 different triangles that we're going to have, and so that would be 36 degrees, which would make each of these half, so this would be 18 and this would be 18. And then we can find the height of the triangle by using the 18 degrees, and we will do tangent of 18 degrees is equal to opposite, which would be 5 over adjacent, which is h, so that would be h times tangent of 18 degrees is equal to 5, and then divide by tangent of 18 degrees to get the height approximately. And so that's 15.39, so the area of the triangle is 1/2 times the base times the height of 15.39. And so that area is 76.95, and then we want to take 10 triangles. So that will be 10 times each of the areas. So therefore that would give us 769.5 approximately. And this is being measured in units, so we'll go with units squared for the area of the entire regular decagon. Question 10. The diagram below shows a circle inscribed in a square. Find the area of the shaded region if the side length of the square is 6 meters. So this side length is 6, so that means that the radius would be 3, because if you go straight across, the diameter of the circle would be 6, so the radius would be 3. We know that the area of the square is 6 squared, so that's 36. We know the area of the circle is pi r squared, so that's pi 3 squared, so that would be 9 pi. And we're only looking for the shaded part, so if we take the total area of the square 36 and we subtract the circle, that's going to give us the 4 corners, so whatever 36 minus 9 pi is. And so that's approximately 7.73, and since we only need 2 of the 4 corners, we're going to take the 7.73 and divide that by 2. And so then the area of the shaded region will be approximately 3.86 units. Oh, nope, this one's meters. It says right there. So meters squared. Question 11. Solve each system of equation below. Write your solution in the form of the ordered pair x, y, and check your solution. So you can solve it any way you want. Substitution, elimination, equal value method, graphing. So the first one on A, I'm going to go ahead and use substitution. I'm going to substitute 2y plus 8 in for x in the first equation. So 3 times 2y plus 8 minus y equals 14. So once again, we're replacing this x with what it's equal to in the second equation, 2y plus 8. And then we're just going to solve that equation that is now as one variable. So 6y minus y is 5y. Subtract 24, divide by 5. Y is equal to negative 2. And then we can take that and plug it back in to the second equation. X equals 2 times negative 2 plus 8. So x equals negative 4 plus 8, or x equals 4. So the ordered pair would be 4 comma negative 2. It does say check your solution also. So if you were going to check your solution, you would just plug the values back into the original equation. So for example, I'll do it on the first one, but not the other two. So 3 times x is 4 minus negative 2 should equal 14. So that's 12 plus 2 is equal to 14, or 14 is equal to 14. So that is correct. But you also have to plug it in the second one. So x was 4. So 4 is equal to 2 times negative 2 plus 8. So 4 is equal to negative 4 plus 8, or 4 is equal to 4. And so there's your check. All right, let's go ahead and look at the next one, B. Both of these are equal to x, so we're going to use the equal value method on this one. Whereas this one over here, we use substitution. So we can just set these equal to each other. 2y plus 2 is equal to negative y minus 10. I'm going to add y to both sides. Subtract 2 over here, so that's equal to negative 12. Divide by 3, and y is equal to negative 4. Plug that back into one of the equations. I'm just going to go with the top one. X equals 2 times negative 4 plus 2, which would be negative 8 plus 2, so x is equal to negative 6. So negative 6, comma, negative 4. And then on C, we're going to use elimination. So you get to see all three methods here. The reason I'm going to use elimination is because everything's lined up. You got your x's, your y's, your equal sign, and then your constants. So, and look at that. Your y's are going to go ahead and get eliminated right away. So we're just going to add these two equations. We'll get 18x. I'll write it plus 0y is equal to 9. And since that's 0y is just 0, 18x is equal to 9. Divide by 18. X is equal to 0.5, or 1/2. Plug that back into one of your equations. I'm going to go with the second one. 2 times 1/2 plus y is equal to 13, or 1 plus y. Subtract the 1, and y is equal to 12. So my solution is 1/2, comma, 12. And remember, when you're solving systems of equations, you're looking for the solution, which is the intersection point of the two lines. Question 12. Gino looked around at the 12 students in his lunchtime computer science club and wrote down the following descriptions of their sex, clothing, and shoes. So you can take a look at the 12 different students. Part A wants to make an area model, a tree diagram for all the possible outfits in the sample space and organize the combinations of sex, clothing, and shoes. We can't do an area model because there are more than 2 events that are occurring, so I just went ahead and copied the tree diagram so I don't have to write all that out. But there's the tree diagram for the possible outfits. Part B in your model or diagram from Part A indicate the probabilities for each option. What is the probability that a randomly selected student is wearing long pants? So as we look at our tree diagram, if we have a male that is selected, here's long pants, and then this one doesn't matter if it's tennis shoes or other because they both are wearing long pants. So we have 1/2, 2/3, and 1/2. So if you multiply that up, you're going to get 2/12. And then on the male, long pants, and other, in terms of the tennis shoes, that would also be 2/12. So we have 2/12 plus 2/12. Now we're going to go ahead and do the female side. So female, 1/2. And then long pants is 1/3. And then once again, the tennis shoes and the other don't matter. So we have 1/2 times 1/3 times 1/2. That's 1/12. And the same thing happens for the next one. We get 1/12. So therefore we add those two in, and that would get us a total of 6/12 or 1/2. So that's the possibility in terms of the students that are wearing long pants. Part C, which outcomes are in the event which is the union of long pants and tennis shoes? Which outcomes are in the intersection of long pants and tennis shoes? So once again, we'll look at the union, in which the union of the long pants and tennis shoes. So let me erase what I have here. Alright, so it wants us to give the outcomes, so we're going to do some labeling here. For the gender, we're going to do M and F. For the clothing, we'll do L for long pants, shorts, and then D for dress. And then tennis shoes, we'll just do T and then O. So when we write our sample space here for the union, which is this or this is going to happen, so we'll do long pants or the tennis shoes. So we have male, long pants, and then tennis shoe or other because it has the long pants. So that'll be, we'll do male, long pants, tennis shoes, male, long pants, other shoes. We can also do male, shorts, and tennis shoes. So male, shorts, and tennis shoes. Once again, it's looking for long pants, and the union is then the tennis shoes. So one or the other. And that's it for the male side. So then for the female side, we have female, and then we can do long pants, and once again, tennis shoes or other, doesn't matter. So female, long tennis shoes, female, long pants, and then other. And then we can also do female shorts, tennis shoes. So female shorts, tennis shoes. Let's see. And then female dress, tennis shoes. Female dress, tennis shoes. So it looks like we have 7 different options there. Alright, and so once again, this represents the union. Now if we go and do the intersection, now we're looking for they have to both occur. So if they're both going to occur, then we're going to go male. It has to be long pants, and then it has to be tennis shoes. So M, L, T, and I can't go any other option because they both have to occur. So then I'll do the female, long pants, tennis shoes, female, long pants, tennis shoes, and then those will be the only 2 because both events have to occur with an intersection. Question 13, multiple choice. What information would you need to know about the diagram below in order to prove that triangle ABD is congruent to CBD by side angle side congruency? So we already have, we have 90 degrees here, so there's an angle. And then if we're going to do side angle side, we need to know that this right here is congruent to itself, which is the reflexive property. And then we would also need to know that side AD is congruent to side CD. So that's probably the one that we need to add because we know the reflexive property that B and D are line segment BD is congruent to itself. So where's AB or AD is congruent to CD, this one right here. So that's the piece of information that we would need to know. The other 2 we know based off of the diagram.